6 months after the most powerful telescope ever built was launched into space, a monumental breakthrough began to unfold, one that is reshaping the way humanity perceives the cosmos. The James Webb Space Telescope, or JWST, achieved what had long been considered the realm of speculative science fiction, the apparent discovery of an entirely separate universe. This astonishing revelation emerged during a deep field observation campaign designed to study the earliest epochs of galaxy formation, yet, rather than simply uncovering new galaxies or clusters, Webb's instruments detected a mysterious patch of space. It emitted signals so alien, so entirely unaccounted for by known physics, that the scientific community felt compelled to explore an idea once confined to theoretical musing: an alternate universe. The journey to this discovery began as the telescope captured faint infrared light from the most distant reaches of spacetime. It recorded a signal pattern that confounded every existing model. These signals didn't match the known cosmic microwave background, nor did they conform to any predictions involving gravitational lensing, quasars, or other high-energy phenomena typical of our universe. At first, scientists suspected corrupted data or misinterpretation, but repeated observations confirmed the anomaly. The region, located at the farthest observable distance beyond the epoch of reionization, was producing structured, yet unclassifiable emissions, initially dismissed as a statistical outlier. This region continued to reveal consistent energy distributions and patterns that bore no resemblance to any galactic formations in our known universe. Even more remarkably, the laws of physics seemed subtly distorted within that section of space. Gravitational behavior didn't align with standard predictions, light refraction was unusual, and thermodynamic interactions defied expectation. The readings suggested not just a few stars or galaxies behaving strangely, but a complete system governed by entirely different fundamental rules. As further observation time and resources were devoted to the anomaly, the scientific picture grew more compelling. It became evident that JWST was not merely peering backward through time, but perhaps sideways across the very fabric of existence itself. The data pointed to a distinct continuum of reality, one not extending from our universe, but self-contained and complete. The implications were staggering. If the signals truly originated from a separate universe, then JWST had just pushed the frontiers of cosmology beyond the Big Bang and into the territory of the multiverse. The idea of a multiverse, a collection of alternate or parallel universes, has long existed as a speculative extension of quantum mechanics and string theory, but it had never been grounded in observational evidence until now. Webb's unmatched infrared capabilities, far surpassing those of Hubble, gave it the ability to peer into realms previously thought unreachable. What it may have uncovered was more than theory, a measurable indication of quantum interference cosmology. These were light waves whose interference patterns didn't behave according to our universe's physical laws. In practice, this suggested that Webb may have detected the outermost edge of our universe where it may be touching or even brushing up against another. The energy signatures didn't resemble dark matter interactions or gravitational lensing distortions. Instead, they revealed a cohesive, repeating pattern, something like a fingerprint, yet entirely foreign to known space. As scientists scrutinized these patterns more closely, they realized they weren't looking at reflections or echoes of our own cosmos. These were coherent structures formed under completely different physical rules. Astronomers and physicists began re-evaluating the very foundation of cosmological theory. What if our universe, long considered the totality of existence, was just one of many universes, perhaps infinite, each with its own constants, laws, and even timelines? Some might host entirely different forms of life. What Webb had observed may not have been just another distant galaxy cluster or a supervoid. It could have been the visible edge of another universe, temporarily revealed through an unknown process. This possibility raised numerous hypotheses. One proposed a momentary convergence or cosmic alignment, allowing light from another universe to bleed into ours, a kind of aperture in the fabric of space. Others theorized a permanent interface, where different universes exist side by side, separated by delicate but stable boundaries. Some turned to quantum entanglement on a cosmic scale, or Brownian collision models from higher dimensional theories once confined to blackboards, and thought experiments were being seriously revisited in light of this new data. The scientific importance of such a discovery goes beyond academic wonder. If verified, it would offer a once-in-history opportunity to study the laws of an entirely different universe and compare them to our own. This could help address some of the most enduring questions in physics. Why do our physical constants have the values they do? Why is there something rather than nothing? What caused the Big Bang? Answers to questions that had long eluded science might now be within reach through the study of this neighboring realm. This newfound universe offered more than alternative galactic structures. It challenged the very nature of time. The light patterns revealed that time there didn't flow the same way it does here. Some regions within the anomaly pulsed rhythmically, as if time itself behaved in a non-linear or oscillating fashion. The implications for theoretical physics were deep and unsettling. If time and space could behave differently in other universes, it would mean that our own understanding relativity, thermodynamics, quantum mechanics might not be universal truths, but merely local rules. Excitement erupted across the global scientific community. Observatories began coordinating their efforts to study the phenomenon from other wavelengths. Radio telescopes, X-ray observatories, and even neutrino detectors joined the collaboration. While none could match JWST's sensitivity in the infrared spectrum, they began finding corroborating anomalies, slight deviations in the cosmic background radiation, unexplained high-energy particles reaching Earth's atmosphere, and unusual gravitational wave signatures hinting at disturbances from beyond our known cosmological boundary. Theoretical work exploded. Astrophysicists proposed new models explaining how a neighboring universe could coexist with ours without violating fundamental conservation laws. Some envisioned a cosmic foam of higher dimensions, where universes exist like bubbles in a field of inflating space. Others returned to the idea of bubble universes forming in an inflationary field, each spawned by random quantum fluctuations. These weren't just ideas anymore, they were becoming the scaffolding for a new understanding of reality. Meanwhile, JWST continued to refine its observations. The images revealed that this alternate universe had galactic clustering of its own, but not in forms familiar to us. Instead of spirals or ellipses, the structures were webbed together in fractal-like geometries possibly shaped by alien gravitational behaviors. Light from these formations didn't just shift due to distance, but showed changes from some unknown influence affecting its spectral signature. Was it time dilation, space curvature, or something else entirely? No one could say. These findings captured the public imagination. Images circulated widely, leaving the world in awe. The media struggled to convey the significance in terms that matched its scale. To many, it was reminiscent of Galileo's first telescopic observations, only amplified by the realization that we may not just be insignificant in the cosmos, we may even be alone in having a cosmos at all. Naturally, religious, philosophical, and existential reflections followed, but scientists remained focused on understanding and explaining the data. Every day, more findings emerged from JWST's vast data streams. Artificial intelligence systems sifted through these enormous information sets and kept identifying behaviors inconsistent with the known universe, adding weight to the growing conclusion that this wasn't a strange corner of our cosmos, but a true interface with another. The scope of inquiry shifted. No longer was the question, is this real? Now it became, how is this possible? And what does it mean for us? Perhaps the most thrilling part of this revelation is the knowledge that we are still only at the beginning. JWST, still early in its operational life, continues to enhance its focus and increase its resolution. Each new image, each new measurement, is helping lay the foundation of a science that may one day be called interuniversal cosmology. Already, future instruments are being conceptualized devices designed specifically to detect and study such anomalies. This entire new frontier, one that had only existed in theory until now, has been opened up thanks to a single telescope and a singular moment of cosmic clarity. What are your thoughts on this extraordinary discovery? Could this be the beginning of a new era in science and understanding? Let us know in the comments, and if this subject fascinates you, don't forget to like and subscribe for more updates on this remarkable journey. Thank you for watching.